So for number 7, in a plane, 4 circles with radii 1, 3, 5, and 7 are tangent to line L at the same point A, but they may be on either side of L. Region S consists of all the points that lie inside exactly one of the 4 circles. What is the maximum possible area of region S? Okay. So we have this line L, right? And then we have these 4 circles that are all tangent at some point A, and they can either be on the left side or the right side, right? And we want to maximize the area that's contained within only one circle at a time. So maybe since we want to maximize this area, maybe we want to look at the answer choices and say, like, is it possible to get 84 pi? Well, if you think about it, 84 pi would be the sum of 7 squared pi plus 5 squared pi plus 3 squared pi plus 1 squared pi, right? So it's the sum of all of the possible circles. But if you really think about it, that's not possible. There's no way you could have the areas of all of the circles added together, right? 64, 65, and 9 is 84. Yeah. Right, because 49 and 25 is what? 74. 74 plus 9 is 74 plus 9 is 83. Yeah, 84. So 84 is not possible, right? But what about 65? Is there any way to get 65 as an answer? Well, what if we have the 7 by itself on one side, right? So put the circle with the radius of 7 on one side, right? And then put all 3 of the other circles on the other side, right? So this is 1, this would be 3, and then this would be 5, right? Well, how much would be the area in just one of the circles? Would just be this outside part, right? Which is basically just what? 25 pi take away 9 pi, or 14 pi, 16 pi, sorry, 16 pi, right? And this would give you what? 49 pi. So what do we get if we add 16 pi plus 49 pi? We get 65 pi. So it is possible to get choice D, right? So sometimes using the answer choices can help you to arrive at the answer. Okay, so in that case, that was how we wanted to do it, right? Okay, number 8. Mr. Shao places all the integers from 1 to 225 into a 15 by 15 grid. He places 1 in the middle square and places other numbers 1 by 1 clockwise, as shown in the part in the diagram below. What is the sum of the greatest number and the least number that appear in the second row from the top? Okay. So basically, like, we're going around and making this sort of spiraling pattern, right? Like 1, 2, 3, 4, 5, right? Sorry. Let me undo that. 1, 2, 3, like this, right? And it's going to continue going around like that, right? Now, one thing you'll notice is that if you look at this diagonal here, right, like 1, 9, 25, that's 1 squared, 3 squared, 5 squared, right? So it's odd squared. So 7 squared, 9 squared, 11 squared, 13 squared, 15 squared, right? So, well, what does that tell you? That tells you that if we keep doing this, right? If we keep going along that diagonal, we're going to have 7 squared, 9 squared, 11 squared, 13 squared, 15 squared, right? So the 225 will be at the top right corner. Here we'll have 13 squared, and we want to know what is going to be the largest and smallest values in that column. Well, obviously, since the pattern is going this way, right, the smallest number is going to be over here. But notice it won't be the number that's all the way on the left. Because remember, once we get to 13 squared, it's going to spiral around, and it's going to go up until it hits 15 squared. Because 15 squared is the maximum. So that means that the number that's over here has to be less than 15 squared, but it's going to be greater than 13 squared. So now what number is going to be here, the smallest number in the row? Well, if we think about it, like, we have 1 here, right? We have 1 over here. So that leaves us with 13, which means that this number has to be 13 squared minus 12. right? So I'm going to write it over here just because not a lot of room. So the number here has to be 13 squared minus 12, right? Now, what about the number that's all the way to the left? Well, if we have 15 squared here, then that means if we do 15 squared minus 14, we end up here, right? This number will be 15 squared minus 14, which means if we go one more down, that's going to be 15 squared minus 15. So that's going to be that number, right? Or sorry, this number. So now so this will be the smallest and this will be the largest. So we just need to add these together. So 13 squared plus 15 squared minus 12 minus 15, 169 plus 225 minus 27, and that gives you 367. Okay, 367, right? So that's going to be choice A. So the answer is A. All right, so that one's sort of a logical thinking problem, right? It's sort of a logical puzzle, right? So those kinds of problems can be fun, but they can also be very challenging, right? Okay, number 9. The point PAB in the XY plane is first rotated counterclockwise by 90 degrees around point 15, and then reflected about the line y equals negative x. The image, oops, it got a little cut off at the side there. The image of P after these two transformations is minus 6,3. What is B minus A? Okay, so when we're trying to do these multiple transformations and we're given the result, then obviously we want to work backwards, right, to get to our starting point. So we're at negative 6,3, right? We want to work backwards to determine, like, where did we start? Well, the second thing that we did, the last transformation we did was reflect over y equals negative x, right? So we need to think about what happens when you reflect over the line y equals negative x. Well, what happens is you take the point xy and it reflects to the point negative y negative x, right? So whenever you reflect over y equals negative x, you will always go from xy to negative y negative x. So that means that this point had to have come from minus 3, 6, right? So that means here, that point was over here, minus 3, 6. Okay. All right, so we got that. Okay, so let's see. So minus 3, 6. Now, what happened before that? We rotated counterclockwise or anti-clockwise 90 degrees about the point 15. So let's find the point 15. That would be here, right? 15. Now, what I always do when I rotate is I make sort of a little triangle shape, right? And I know that's 90 degrees. Now, since we rotated counterclockwise 90 degrees, we have to rotate this clockwise 90 degrees. And when we rotate this clockwise 90 degrees, it's going to kind of look like this, right? Where this distance is 1, right? Because it's the difference between 5 and 6. And then this distance will be 4, because it's the distance between minus 3 and 1. So we're starting at the point 15, and we're going right 1 up 4, right? So that's going to bring us to what? 2, 9. And it wants B minus A. 9 minus 2 is 7. So the answer is D, 7. Okay. All right. So the key for that problem was to work backwards. And hopefully you have like a pretty good knowledge of geometric transformations, right? Which usually is taught in a geometry class, maybe in algebra 2 or pre-calculus. Okay, number 10. An inverted cone with base radius 12 and height 18 is full of water. The water is poured into a tall cylinder whose horizontal base has a radius of 24 centimeters. What is the height in centimeters of the of the water in the cylinder? So we have this inverted cone, right? And we're converting it to a cylinder, right? The cone has radius 12 and height 18. The cylinder has radius 24 and height h, right? Now, one thing we know is that, well, obviously we want these volumes to be equal, right? So well, what do we know? We know that if we do, what's the volume of the cylinder? 1/3 pi r squared h, right? The volume of a cylinder is 1/3 pi r squared h, right? And the volume of I'm sorry, the volume of a cone, the volume of a cylinder is pi r squared h, right? So we want this to be equal to pi 20, whoops, sorry. Oh, let me draw that better. I'm getting a stylus soon, so hopefully this will look a lot better. Times h, right? And h being our answer. So we can cancel out pi's. 18 divided by 3 is 6. So we have 6 times 12 squared equals 24 squared h. So that means h is equal to 6 times 12 over 24 squared, which is equal to 6 times 1/2 squared, or 6 over 4, or 1.5, right? 3 over 2. So the answer is A, 1.5. So this one was really just about setting volumes equal to each other and, noting sort of the relationship between them. All right. So in my next video, I'm most likely going to do problems 11 and 12. So from 11 to 20, I do the problems in pairs. Okay, so my next video will be 11 and 12. All right. I look forward to seeing you in my next video. Please like and subscribe. And also let me know any suggestions or anything that I can do to improve my videos, please. Thank you.